Here we introduce a new concept, and the concept that we're introducing here is concept of isotopes. And the question says, how many protons and neutrons are in an atom of Tm169? So this convention is used to talk about isotopes, so we have Tm169. And the question is, what does that 169 represent? Well, this 169 here is the atomic mass of this particular isotope. So let me ask you, what are the three main subatomic particles of an atom? That would be the proton, that would be the neutron, and that would be the electron. Of these three main subatomic particles, which are the ones that contribute significantly to the mass of an atom? That would be the proton and the neutron. They have almost identical masses. Electrons are so small in comparison to the protons and neutrons when you consider their mass that they don't really contribute that much. This was discussed in the lecture, but the mass of an electron is almost 1,800 times smaller than the mass of a proton or neutral. Okay, very, very, very small compared to these two. And so for this element is thulium, Tm is thulium, this 169 is the atomic mass. When you look at the periodic table and you find this element, its atomic number is 69 and its atomic weight is 168.934. So now we can make sense of what we see when we look at the periodic table. Why is this value here a decimal? Why do we call it the average atomic mass? The reason we call it an average atomic mass and the reason it's a decimal is because of this idea of isotopes. There are atoms of thulium that have different atomic masses. They have the same number of protons because they're still thulium atoms. If I have 70 protons, I'm not thulium, I'm the next element. If I have 68 protons, I'm not thulium, I'm the element that comes before Tm. Okay, the number of protons can't change, but atoms of thulium can have different numbers of neutrons. And the more neutrons they have, the heavier they are. The fewer neutrons they have, the lighter they are. Okay, that's what an isotope is. Atoms of the same element with different numbers of neutrons make different isotopes. And so this is telling me that this particular isotope of thulium has an atomic mass of 169. So from this information, I could tell you how many neutrons and how many protons are in this atom. So let's figure it out. How many protons would there be in this atom of thulium? It's equal to the atomic number, 69. This is also the number of electrons. How do you find the number of neutrons? Well, the number of neutrons is going to be equal to the atomic mass minus the atomic number in this case. So what is the atomic mass of this particular isotope of thulium? It's given here, 169. What's the atomic number of thulium? 69. We get that here. So the number of neutrons will be equal to 100. So our answer would be 69 protons and 100 neutrons. So that is our answer. For those that would like to see how we get this equation here, please stick around for just another second while I explain it. So we talked about what contributes to the mass of an atom, the main contributors. That is the proton and the neutron. So we know that the number of protons and the number of neutrons equals the atomic mass. of an atom. Let's solve for the number of neutrons. We can do that by simply rearranging this equation. If I subtract the number of protons from each side, I get the number of neutrons is equal to the atomic mass minus the number of protons. Well, what is the number of protons also equal to? The number of protons is equal to the atomic number. So we could just substitute that. The number of neutrons is equal to the atomic mass minus the atomic number. And then there we have the equation that we used to solve this problem.